Hi, welcome back to Mr. Silver's Math. Today we're going to learn and understand polynomial vocabulary. So we got our warm up here. We're just simplifying the expressions, just some review of basic exponent rules. So 2x squared times 10x squared. We multiply our coefficients. 2 times 10 gives us 20, and then you add your powers. These are like terms, so we just add them. We do not change our powers. And then letter C, we have our quotient rule where we divide our coefficients. 25 divided by 15 is 5/3. And then we subtract our powers because they are the same letter. 15 minus 3 is 12. All right, so the big focus for today is on vocabulary. So there's going to be a lot of vocabulary. And with that, we're going to come up with a lot of examples. So a monomial is an expression. Remember, an expression just means that there's no equal sign. So everything that we're doing today is not going to have an equal sign. A monomial is an expression that is a number, variable, or a product of a number and variables. So I came up with 3 different examples to illustrate all 3 of these that are underlined. A number, exactly what it says, which is just a number. A variable, or a letter. I chose x squared. It could be any letter of the alphabet. It could be any power, any positive power. And then product of a number and a variable. So number and variable, 3y to the 4th. Those are just 3 examples. There are literally an infinite amount of possible examples. A term should be familiar because we've talked about a term before. A term is separated by an addition, which is a plus sign, or a subtraction, which is a minus sign. So here's our example, 3x to the 7th minus 2y plus 3. And I've kind of denoted in red the different terms. So this is a term, this is a term, and this is a term. There would be 3 terms there. A polynomial is an expression that includes multiple terms. So an example, negative 12z cubed plus 2z squared plus 5. You could have as many as 10 different terms if you wanted to. But for purposes of this class, we're not going to get that large. Our terms are going to be a lot smaller. The degree of a monomial, so one term, is the sum of degrees of each variable. So here's our example. 7x squared y cubed has a degree of 5. And you may be thinking, well, Mr. Silver, how does that have a degree of 5? I see a 7, a 2, and a 3. We are only focusing on the exponents. I don't care about the 7. That's a coefficient. It has nothing to do with my degree of a monomial. I focus only on the exponents. And it doesn't matter that the exponents are different. It doesn't matter that the variables are different. It doesn't matter. I add those powers together, 2 plus 3. So just like it says here, 2 plus 3. I don't care what the letters are. They don't have to be the same. So my degree is 5 for that monomial. The degree of a polynomial is the degree of the term with the greatest power. So now that we know how to find the degree of a term or a monomial, we want a degree of a polynomial. And that's where we just find the largest power. Just like we did up here, we found the largest degree of all of the terms. So this one, my degree is 2 because it's the largest power, it's the largest degree. And then standard form is a very common direction that you're going to see throughout this unit. Standard form of a polynomial means that the degrees of all of its terms, the monomials, are in order from greatest degree to least, aka largest power goes first, and then the smallest one goes next, and so on and so forth. So 37x cubed plus 2x minus 4. So here's my degree of 3. So the degree of my polynomial is 3, and it has 1, 2, 3 terms. So now that we have that terminology out of the way, let's get more specific when we start talking and classifying about polynomials. If I have something that has a degree of 0, So remember, we said the degree of a monomial is the sum of the degrees of each variable. So if we have a degree of 0, that means we have a constant. It means there's no letters in a constant. A constant has no letters. You've been dealing with constants for a very, very, very long time, since kindergarten. If your degree is 1, that means it's a linear degree, or it's linear. 4x is an example. If it has a degree of 2, it's called a quadratic. 5x squared plus 2, we call this a quadratic function. If I have a degree of 3, that is cubic. So negative 11x cubed plus 2x squared minus 7, this would be a cubic function. If I have a degree of 4, it's called quartic. These are not made up words, by the way. These are all real words that you're expected to know. My degree is 4, so I have a power of 4. That doesn't mean I have 4 terms. Okay? That just means my degree of the polynomial is 4. My quintic means I have a degree of 5, so here's my degree of 5, and notice I don't have 5 terms, and that's okay. I'm just focusing on the degree of the polynomial on this table. And anything that is 6 or above, we just name it by the number. So this would be a 6th degree polynomial, or a 10th degree polynomial if I had a degree of 10. Okay. For purposes of this class, we focus right in here. Okay. We don't really get anything above this. We'll see a few quintics just for naming purposes, but our focus mostly in our class or in next year or the year after is focusing on constant, linear, and quadratic. So now that we can classify it by its degree, we need to be able to name it by its terms. So if it has 1 term, we saw already that that was called the monomial. So here's an example of 1 term. Remember, a term is separated by an addition or subtraction sign, not multiplication. Okay, because this is really saying 3 times x times y. That's 1 term. If I have something that's 2 terms, that's called binomial. Think about a bicycle. Has 2 wheels, 2 terms. Here's my example. If I have something that has 3 terms, it would be a trinomial. Just like a tricycle has 3 wheels. 3 terms. And then anything greater than 4 or greater, is just called a polynomial. So 1, 2, 3, 4 terms, we just call the polynomial. Okay, but these two we are specific because we have specific names for them. Binomial is something with 2 terms, trinomial is something with 3. We deal a lot with binomials and trinomials in our high school career. So now we're going to combine it all together. We're going to complete the table and answer what it's asking. So here's my example. It's asking for standard form, so I want the largest power, largest degree first, and then the next smallest, and then the next. The degree name is 5, because I have my largest power is a w to the 5th, so that means my degree is 5, which means it's a quintic function, and it has 3 terms, 1, 2, 3. So we name it as a trinomial. So the next one, here's what I start with. I need to put it in standard form. So I go through and I look. I have an x cubed, that's the largest power, and then a squared, and then an x, and then a constant. So my degree is 3, that's the largest power I see, which makes it a cubic function. And there are 1, 2, 3, 4 terms. So that makes it a polynomial. Okay, the next one, x to the 4th minus 1 plus 3x. The first term is set, but the negative 1 and the 3x are not in the correct order, so we need to switch it around. So 4x to the 4th plus 3x minus 1. Now it's in standard form. My degree is 4. The largest power is a 4, which makes it a quartic. There are 1, 2, 3 terms, so it makes it a trinomial. And then this one, if you notice, between the example and the standard form, it didn't change. Well, that's because it already was in standard form. Okay, so all I have to do then is now answer the remaining questions. The degree is 1. Remember, if I don't see a degree with that variable, it's assumed that it's a 1. So my degree is 1, which makes it a linear function. I have 2 terms, which means that it is a binomial. And there's 2 more examples if you want to check those out. So the big takeaway from today is naming these 2 things. Okay, we use our degree to figure out the name to classify it. So if it has a degree of 3, it's going to be a cubic function. Degree of 5, it's a quintic function. If it has 2 terms, it's a binomial. 3 terms, it's a trinomial. And a degree of a monomial is the sum of the degrees of each variable.